Hello and welcome to this new video. In this video, we are going to focus on how to calculate the volume of a frustum of a pyramid. In the previous video, we focused much on how to calculate the volume of a frustum of a coin. So now we're just changing the shape to a pyramid. Okay, so let's understand how a frustum of a pyramid comes in existence. So a frustum of a pyramid comes into existence or comes in form when a pyramid, that is a full pyramid, has been successfully cut. Okay, the same way we are cutting a cone for us to remain with a shape called the frustum of a cone. It's the same procedure how we can also get the frustum of a pyramid. So a pyramid can be in a square or rectangular form and many other forms as well. So let's look at how a pyramid. The best example to give of is the three great pyramids found in Egypt. I think these are famously known by everyone. We know these pyramids. That is how a pyramid looks like. It's the best example I can think of giving you. Let's look at how the frustum of a pyramid then is formed. So what I've done is that I've shown an example of the previous video. On the left side, we have a frustum of a coin. Remember what happened for us to form the frustum, or for us to come to having the form or the shape of a frustum of a coin. We had to cut a full coin, and what remained was a frustum of a coin. So that's the same procedure that we take or undertake for us to have a frustum of a pyramid. So on the right side, you can see that a pyramid has been cut, and the upper part remains a small pyramid, and the lower part remains a frustum of a pyramid. How can we calculate the volume of frustum of a pyramid? The volume of frustum of a pyramid is defined by different types of, or different formulas, I would say. One of the formulas I prefer using is the one you can see right now. And this is for method 1. This is a formula you can use when you do not want to calculate the full height of the full pyramid. You just want to go in straight. So this is going to be method 1 formula. So when you have height divided by 3 multiplied by the area of the upper base plus the area of the lower base plus the square root of area of the upper base times area of the lower base, you will get the volume of the frustum of a pyramid. So A is representing, we have A1 and A2. So A1 is area of the upper base and A2 is area of the lower base. So let's look at a practical question that we can use to solve. I have sampled again from the ECZ past papers. This is 2020 GCE paper 2. And the question says, the figure ABCDEFGH below is a frustum of a pyramid. EF, GH, and ABCD are squares of sides 8 centimeters and 12 centimeters respectively. So we can see that the upper base is a square with 8 centimeters. That simply means that FG is 8 centimeters, GH 8 centimeters, and EH 8 centimeters, EF also 8 centimeters. The height that we've been given for the frustum, I think you can see that is 3 centimeters over here. We've been told to calculate the volume of this frustum. We can also see that the lower base is AB having 12 centimeters. That means BC is also 12 centimeters. CD and AD is also 12 centimeters. I know this because we've been taught that the frustum of a pyramid has EFGH and ABCD squares. Therefore, we can look at how we can solve this. All right, now let's look at how we can solve this problem, okay, using the formula that we adjust from that we've just discussed. All right, after a pyramid was cut, this is the frustum of a pyramid that remained. According to the question, it had the upper base, which is a square of length 8 centimeters, and the lower base with a length of 12 centimeters. This simply means that FG is 8 centimeters and GH is also 8 centimeters. HE and EF is also 8 centimeters. Same applies with the lower base, which is AB with 12 centimeters, meaning BC is also 12 centimeters, and CD with AD will also be 12 centimeters. So the upper base is 8 by 8, and the lower base is a square of 12 by 12 centimeters. Let's look at the formula that we can use to calculate the volume of this frustum. So we know that volume is equal to height over 3, the area of the upper base, plus the area of the lower base, plus the root, the area of the upper base, times the area of the lower base. So let's begin the actual calculations. So we'll say the height is the height given for the frustum. All right, so therefore we'll say the height is 3 over 3. How do we get the area of a square, which is the upper base? It's 8 by 8, and that will give us the square of the upper base, plus, and that will give us the area of the upper base, plus 12 by 12, that will give us the area of the lower base, plus the root. So we'll have 8 by 8, 12 by 12. Okay, therefore we'll say that will give us 1. 3 divided by 3 is 1. 8 times 8 is 64, plus 12 times 12 is 144, plus the root. 8 by 8 is 64, times 12 by 12 is 144. Okay, so we know 1 multiplied by everything in the bracket will be everything in the bracket, so we can get rid of the 1. Okay, therefore we will now do the additions. Okay, what is 64 plus 144? That will give us 208 plus the root. All right, so let's go on a calculator and punch our root and see what we'll get. Okay, so now that we have our calculator, the first thing we have to do is get the product of 64 times 144. So what is 64 times 144? That is 9,216. Therefore, all I have to do is square root that one. All right, so I can take note that what we have is 9,216. Then I have to square root that. All right, so what I'll just do is I'll clear that. Okay, let me move this sign because I need my square root. Square root of 9,216. That is 96. So I'm going to take note and say 208 plus 96, which is the root. Then we can say what is 96 plus 208. That will give us 304 centimeters cube. That will be our volume. I hope that has been understood, And if there are any questions, please feel free and ask. However, this is just our method 1. We are still going to do method 2, and then you can use the one that is comfortable or the one that you prefer.